Hello there, this is Ginés Ibáñez, your technology teacher. I'm going to show you what you have to do with these parts. Here we have parts number 1, 2, 3, 4, and so on. So first of all, I want you to write here part 1 because we are going to draw part number 1. Okay? Part 1. And then here you have to write views because we are going to draw the views. I want you to take in your notepad 4 squares for this line. 4 squares, each square here in this part, as you can see in this paper. Okay, so we are going to take 4 squares, 8 squares here, 4 and 4, here another 4 and 4, that's it, 8, 4, and here 4 plus 4 plus 4, 12. Okay, so doing this we have to take 4, 8, as I said before, another 8 to the left, 4 downwards, 12 to the right, and finally 12. Okay, this is the part. So we are drawing the front view. Now you have to imagine the part rotating like this to the right to see the left side. Okay, since this is the front, this is your left hand, this is the left side view. So to draw the side view, imagine the part rotating to the right. So you have to draw the part exactly as you can see it here from this point of view, from the left side. So you have to draw this rectangle and this one, following the same things I said before about the proportions. So 12 squares, 12 squares, 12, 12, and finally another line here. This is the left side view, and it is compulsory to draw this left side view to the right, okay, on the right hand, okay, like this. Very important. Don't move this drawing upwards or downwards. Must be perfectly aligned, must be a continuation of these lines from the front view. Okay, doing the same again. Now you have to imagine the part rotating like this, and you have to draw this part from the top, drawing this rectangle on the right hand. More important things. You have to leave the same gap between this view and this view, and between this view and this view. This gap and this gap, this distance and this distance is the same, must be the same. Here I'm leaving 4 squares and 4 squares. You can take, for example, 5, 6 squares, it doesn't matter, but the same. Okay, so 4, 6, 8, 10, 12. The same again here. Another 8, 12, downwards. That's it. Okay, now the dimensioning. We are going to do this. In real life, we have 3 dimensions. width, height, and depth. Okay? So, talking about the width. We need to give two distances. This distance and this distance, but instead of this, we are going to give one of them and the overall, the total distance, the total width. So, imagine we are using a scale. You have to write the scale here, a scale 1 to 2. Okay? This means that the real part is twice as big the drawing. 1 centimeter in this drawing will be 2 centimeters in the real part. So, what is the distance here from this corner to this corner? We have 4 squares, 4 millimeters each square. So 4 millimeters, another 4 millimeters, 4, 16. The distance from this corner to this corner is 16 in the drawing. Since we are using a scale 1 to 2, the real part will be 32 millimeters long. This line, I'm talking about this line. Okay, following the same thinking, the number you have to write here is 96. Please pay attention, observe that the distance from the view, from the object to the first dimension line is 3 squares, must be 3 squares, and the distance from one dimension line to the next is or must be 2 more squares. These lines are called extension lines. This extension line, or an extension line generally speaking, must start here, 2 millimeters beyond the part, beyond the view. You have to extend the line 2 millimeters beyond the dimension line. The numbers must be orientated like this, but in vertical dimension lines, the orientation of the numbers must be this. So you can read the numbers from the right hand of your paper. Okay. Remember this. Here we have width, height, and now finally you have to draw here the depth. Okay, finished. Now we have to draw the cabinet projection. So write here the title for this cabinet projection. And draw the front view in the same way you did it before. Okay, 4 squares, 8, 8, 4, 12, 12. And now we are going to draw diagonal lines like this. You have to be sure that you are passing through every single corner of every square to be sure you are following the 45-degree direction. Okay, not like this, not like this, but this 45 degrees. Okay, this cabinet projection obviously is a projection, kind of projection. So, what is a projection? As you can see here, a projection is a flat drawing where we are distorting the drawing to create the illusion, the sensation of 3 dimension, the illusion of volume. For example, this angle here in the drawing is 45 degrees. Okay? But in real life, the same angle is 90 degrees. This angle here in real life is 90 degrees as well, but here it is 135. Understood? That's it. In the same way, we are changing distances. For example, this line is supposed to be 12 squares, but for diagonal lines, generally speaking, we have to take half the squares that the line is supposed to be. So 1, 2, 3, 4, 5, 6. 12 squares, we take 6. Okay? Okay. Finally, you have to draw here the isometric projection. To do that, you have to take your isometric paper, and now you are going to take 3 squares, each square of the real part. So 3, 4, 5, 6, 7, 8, 9. Now 6, 9 squares, this line, another 6, 3 squares downwards. It is almost done. Okay. Pay attention. This is the isometric projection. The difference between the cabinet projection and the isometric projection is that here in the isometric projection, the three main directions of space are these ones: vertical lines, diagonal lines to the right, and diagonal lines to the left, orientated to 30 degrees, not 45. So here we have no horizontal lines. We have vertical, diagonal lines to 30 degrees to the right, 30 degrees to the left. And in cabinet projection we have vertical, horizontal lines and diagonal lines to 45 degrees. Okay? Notice the difference. Now you have to crop your isometric projection and stick this here, okay, like this. So one part, one page, okay. So now when finished, you have to do exactly the same with part number 2, doing exactly the same. For example, for the cabinet projection, now this is the front. Our front view will be what you can see from the direction of the arrow, okay? Because you could take this as front view, or this, or this. So we are going to take exactly what you can see here from the direction of the arrow as front view. Okay, so to draw the cabinet projection, you have to draw this. 4 squares, 4 squares, 8 squares to the left, 4 and 12. This surface is this, okay? And here we have another one behind. So from this, now you have to take squares, you have to draw squares, draw lines for this, like I'm showing. Taking this line is supposed to be 8, so you have to take 4, 4, 4, okay? 4 diagonals. And here, from these corners, you have to draw vertical lines. Here, a horizontal line like this. So the difference is that in the previous part we have all the front view in one single plane. So we draw the front view and then the diagonal lines. And here we have the front view in two different planes. This and this one. So you have to start by drawing what you can see on the foreground, tracing the diagonal lines after that, and then draw the other surface that you have on the background. Okay? Okay, that's all. See you soon in class. Bye.